Hello, welcome to the yet another session. In this lesson, we are going to concentrate on arithmetic progression. We are going to learn some interesting patterns. Okay, you would have seen some numbers like number patterns or sequences. You call them sequences, arranged in some specific. They might have some relationship between the numbers. Okay, say for instance, I can give you a few examples like 1, 4, 9, 16, 25, 36, and so on. Okay, so you one look at it, you can just find out that it is the square of natural numbers, right? This one is 1 square, 2 square, 3 square, 4 square, 5 square, and likewise it is going. Okay, we'll take another series like 1 1, and then adding the first two, the consecutive two numbers. If you add, and you can write the third one. Okay, so that's 2. 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 5 is 13, and likewise this goes. Okay, or you can also have like this, like 7, 14, 21, 28. So all these are series only. You can have any such series, but one thing you find here is somehow they are related to each other, right? The two consecutive terms are related in some manner or the other. So you call all these a sequence. Okay, but when an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number. Okay, by adding a fixed number to the preceding term except the first term. Okay, say for instance the first term, say I take it as 5. Okay, and my second term is 15. The third term is 25. The fourth term is 35. Likewise it goes. So I can say this is a arithmetic progression because you find that I keep adding 10 to my previous number, right? Except the first term, I keep adding a fixed number, that is 10, to each term to get the next term, right? So an arithmetic progression is also a sort of sequence or series, but here what we do is we get this list of numbers by adding a fixed number to the preceding term except the first term. Okay, so when I say term, you might be confused, like what am I talking about? The term is each number in this list. Say for instance, if my list is 2, 4, 6, 8, and this is the arithmetic progression AP, then each number in this series is a term. This is one term, this is yet another term, this is another term. So all these you call it as terms. Okay, so I have written 4 terms here, and the rest is I've just left it. It is to infinity. Okay, and the next thing you should know is the common difference in an AP. I said in an AP we just keep adding a number, right? A constant to the previous number, and that's how we get an arithmetic progression. So here, say for instance, if I take an example like, let's take 6, 12, 18, 24. If this is one series, one arithmetic progression I am giving, you can find the common difference. That is, I told you, you would be adding a constant, right, to each term. That is what is called common difference. Okay, in this previous example I kept adding 10, so the common difference between the numbers, between the terms, is 10. So that is how you get this. So the common difference here would be the difference between these two numbers. The difference between these two numbers is 6. See, and it is plus 6, right? Here also it is plus 6. So this is the common difference. Okay, the difference between the two successive terms is the common difference. And again, a common difference can be positive. Here it is positive. It can also be negative, and it can be 0. For negative, I can give you an example. Say if I write 50, 40, this is yet another arithmetic progression, okay? 30, 20, 10, 0, negative 10. Likewise, it keeps going, okay? Now you find I keep reducing, minusing 10 from each terms, right? So the common difference here is minus 10, okay? So here the common difference is minus 10 throughout. It can also be 0. Say for instance, if I just write 2, 2, 2, 2, then this is also an arithmetic progression with the common difference. I haven't added anything, right? It's plus 0. So the common difference can either be positive or negative or 0. To find the common difference, you have a formula. The common difference we normally denote by the term D, and the common difference could be found by subtracting the first term from the second term. Always any two terms you can take, okay, any two consecutive terms you can take, and from the second term you just subtract the first term, you get the common difference. In the first case, I number it. This is 1, this is 2, second example, and this is 3, right? See how I'll show you how to find the common difference for 1. It is 6, 12, 18, right? You can take any two terms. I just take 24 and 30, okay, the two terms. So second term minus the first term. The two terms I've taken is 24 and 30. I just subtracted the first term from the second term, and I get the answer as plus 6, right? For the second one, you can do the same. Take 50 and 40 from the second term, take away the first term, and you get the common difference, that is minus 10, okay? And for the third example, it is the second term is 2 and the first term is also 2. So your common difference is 0. You know what a term is. We know the common difference here, right? And then I would like to tell you one more thing. The arithmetic progression which I gave you, it's 6, 12, 18, 24. Likewise it goes, right? Here, each terms you can represent like A1, A2, small letter A, okay? A3, A4, dot, 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 like you have n terms, okay? Just imagine n terms. Here it would be A subscript n, okay? So these subscripts, or you can also use the letters T1, T2, T3, and so on, okay, till Tn you can use this. So here the subscripts which we write here along with this letter, these letters denotes the position of the number in that AP, okay, which position. Say for example, if I say A2, it is the second number of the arithmetic progression. If I say A10, it is the 10th number in the arithmetic progression, okay. The subscript denotes the position of the numbers. And you can also have finite arithmetic progression, okay, which means, say for instance, I can give you an example: 5, 10, 15, 20 till 100, okay. I know the arithmetic progression is till 100, right? So I know where it ends. If you know the end point, of an arithmetic progression, then it is finite arithmetic progression. So, infinite arithmetic progression says that you don't have the last term and it is left like infinity. 5, 10, 15. Likewise, it keeps going. Okay, it is infinity. We don't know what is the last term. So, arithmetic progression can be finite or infinite. Here, I've just mentioned the basic things about arithmetic progression. Maybe we can do problems on each of these in the next coming videos. Till then, bye.